Hello everyone, thank you very much for joining me again. Another essential discussion on JPA and Hibernate. Today we discuss about using native queries. It's an important subject because a lot of developers misuse native queries with ORM frameworks. You will see that even though there are cases where they are the best practice, let's say, where they can be used, in most cases, using native queries might be a problem. So even though you might feel more comfortable with native queries because you've learned SQL and we started with JDBC, you will see today when is most appropriate to use native queries with a JPA implementation and an ORM framework in general. Thank you very much for being here with me. I already see your messages in the live chat. If you are here with me live, you can, as usual, leave me questions in the live chat or start discussions or whatever you want to say there, even just hi. And if you are not here live with us, this is a recording. You will be able to see it later and you will be able to ask questions and start discussions in the comment section. Let me share you my screen. And I'm gonna already jump into the subject. As usually, I reuse one of the projects from the previous lessons because it doesn't make sense to lose a lot of time rewriting the same stuff that you already know. You can see I'm inside the transaction here as I used to be since, I don't know, the first lesson of this stream. And I have a few tables, 3 tables in a database. Course enrollment student. We will most likely only use one of these today because I don't care too much about the relationships between or among the tables. Today we only discussed technicalities. We already went through relationships of different kinds. We have used operations on the context directly. And you also learned to use JPQL queries in the previous lessons. But when using JPQL queries, you know we have created them directly. I have also shown you how to use named queries. What you need to know is that you can use native queries as well. What are native queries? They are queries written directly in the language that your DB technology understands. So say I'm using MySQL, I'm pretty sure MySQL will understand this. Select everything from student. You see this is a totally native query which I can just take and run directly here in my client in the MySQL workbench, which is the client I'm using, and it works. It's not what you have learned by now, and it's not a JPQL. Remember, the JPQL would look something like this: select S from student S, and it's a very big difference between how the JPQL looks like and what these things represent here. So this student here, it's an object. This is a declaration. You can see the standard syntax for declaring an object, and then you use the object here because remember the JPQL is something that we think it's run on the context, on the JPA context now, while when we discuss native queries, these are the queries that will in the end be run directly on the table. So this student here, it's a table. This student here, it's a class. It's a very big difference between what this is and what this is. Now, normally we avoid as much as possible using native queries with ORM frameworks and especially with JPA implementations such as Hibernate. Main reasons are that going with native queries, you will jump over some of the things that Hibernate or whatever other JPA implementation offers you comes out of the box with, like caching, for example, like checking for SQL injection in some cases. and some improvements even regarding the performance and indexing of the queries. So when you write the queries directly like this, you are already stepping over the entire philosophy for the framework that you have chosen. Remember, you choose an ORM framework, which is object relational mapping, because you want to use objects. So you are working with objects in your app, and you allow something abstract behind the scenes to help you with translating those operations in the most performant way as and be run on the database. No, so this is one of the reasons, and the main reason why we avoid using native queries. The second reason is, of course, the independence we create to the database. Now, normally you'll say, hey, it's rather less likely to change your DB technology. It happens, but not that often. No, how often did you see someone changing from, I don't know, starting with Postgres to and then having to change completely their persistent layer to Oracle, for example? I've seen that, you know, I've seen that probably once or twice in my career, but it's not something that you see like every now and then. So let's say maybe when you use an ORM framework, you don't necessarily use it because you want to or not as a main thing being the complete decoupling from the persistent technology, but that's also one of the points. No, it's also keeping your layers apart as much as possible in your architecture. But yes, so you can run native queries even though it's not advised. Mind that in many projects where I've seen native queries used, I've seen them used because developers were not comfortable with JPQL. Basically, in many cases where I've even asked, hey, why did you write this instead of this? Because this one would have been better. In that case, it would really have been better because it didn't really make any sense there where they were using native queries almost in the whole application, and in the end, it's not even why do you use Hibernate anymore? Why do you use it anymore if you go with native queries? Like just for the relationships themselves doesn't really make sense. No, I mean it's you jump over like maybe 3/4 of what Hibernate offers you because of that. And in most cases was, hey, I didn't even know that JPQL exists. I didn't know that I can use JPQL or criteria query or something else. Or I'm afraid of JPQLs. I don't know how to write them. Even though, as I have proved in the previous lessons, they are very, very much similar to native queries. No, it's just a psychological effect that you feel it's something different and hey, I have to learn something different. But yes, do learn them because they are important and it makes sense in an application using Hibernate, for example, to use JPQL and not native. Now let's also talk about how to call a native query and when is appropriate to do that. Because again, I said, hey, there are cases where it's appropriate and using native queries is a good solution. No, it exists there because there are cases where you can use them, and I will teach you which are those cases, but also how to sometimes avoid needing to write native queries directly, some best practices in these regards. First of all, let me actually read some of your comments and see if you have questions. So when using basic annotations, I encountered that all the primitive data types are always fetched eagerly. Correct. That's how JPA specification states and how all the implementations work. Even though it is said to fetch lazy. No, I don't believe that. If you give me an example, I will prove you are wrong. Okay, is this supposed to? No, it's not, and it's not working like this, I promise you. So probably you might not understand the difference between eagerly and lazy. Lazy means it's not taken by default, but when you use it. Now, if you did something like this, if you put it on lazy, but you are still printing that in the console or something like that, remember any usage of that attribute will trigger the query. So it's very likely that's what you are doing. In many cases, there are students actually who are in the debug mode and you're triggering the lazy attributes because they were actually debugging it. So be very careful what you are doing. Remember, lazy means it's not retrieved if you don't use it at all, even if that usage is a simple debug or log. Okay, if you do that, you've used it, it will be run. Okay, so that's probably where you make a confusion. But no, I promise you, Hibernate works correctly. If you put that on lazy, it will not be retrieved as long as you don't use that attribute. Okay, and now going back to our, and I hope that answers your question. Now going back to this, how do I run this? No, well, it's very simple actually, and very similar to using JPQL. You had the create query for JPQL, and you even had a create named query that we have used. Now it's a couple of methods that we have used in the previous lesson. Now you have also you have seen it already. Probably you have a create native query. So what you do is say create native query, and usually depending on what you select here, if you know it maps to some object you already have, you will most likely want to map it to that one. Otherwise it will come as a collection, and it will be more difficult to parse what you have there. But again, it really depends a lot on how you write the query. Very similar to what you've learned about the projection when we discussed JPQL. But in my case here, it's clearly that I'm selecting from the students table, so I'm pretty sure this should fit correctly on the student type like this, and then I get it as a query. For reasons I don't know why, they didn't implement typed queries. So even if I specify the class here, I cannot take it as a typed query and provide a type as a generic type. You see that all the create native queries methods return directly the query super contract because query is inherited by typed query. We might have already discussed that. So if you go here, you will see that typed query, it's actually extending from query. That's why I'm using the term super contract, because it's superior to typed query, but you don't have any other chance. But anyway, you run it the same. You can now set the parameters, and you can do whatever you want with your retrieved objects. So students, in my case, we don't have to waste a lot of time doing spectacular things. I will just print it in the console and demonstrate, because now it's, regardless it's a simple query or a very large one, it's no difference on how you call it. Now you know how to call it, and we will see now that the students will be displayed in the terminal. Okay, fine enough, we can see them. Moreover, of course, you can see that the Hibernate ran exactly the query I gave. So normally I give a query, Hibernate will take that query. And you probably remember when we were using JPQL, you would have seen a strangely translation of that JPQL into the query, and that's where some of the magic comes behind the scenes. Is you use a JPQL, but it somehow sometimes get translated into a different thing that you would have expected. In most cases being good, because it's basically an optimized solution. But you also know, and I have taught you, you have to be careful, because sometimes if you wrongly create your design, you might end up with n+1 queries or unneeded updates and stuff like that. But with native queries, you will get exactly that query, because that's what happens. It just takes the query and run it on the database. You don't have anything spectacular happening there. Now, again, we do use native queries when you have something special that can only be some use case that can only be achieved by some native function of that specific database technology you use. If you have something that can really not be solved otherwise than by using some native capability of your DB technology, then the only solution for you will be to use something native. Okay, but that's the only case where I recommend you use something native. Okay, it's all the other cases where what you write, and in most of the cases apply, if what you write can be translated with something that is Hibernate specific or JPA specific, to be even more abstract and go to the specification level, like criteria query or like JPQL, do use that instead of the native queries. Do use native stuff only if that's the only thing that can be used to solve your case. Sometimes, and now I'm gonna go to solve some other things that I know trigger developers to use native queries. Sometimes out of the fear of using large JPQLs, because you see in the real life JPQLs will not be a select S from student S. They can be very large. They might use joins, operators, and all the other stuff that we have discussed in the previous lessons. And sometimes they are so complex that developers tend to try avoiding it. And maybe I've seen places where teams were working like with DBAs, and DBAs were providing, I don't know, kind of a query that was quite large, and then the developer was either lazy or didn't know how to translate that query, and then they were using the native query just because, and they said, hey, this is a very large one, and I don't know how to translate it. But in many cases it really happened that using that native query was not necessarily the only solution they would have had. And what developers sometimes miss is the fact that in many cases they can also use views on the database. And in many cases, or like those that I was telling you, you had a large query, but that large query could have been reduced to a view, so that from inside your app you didn't have to put the whole query. You could simply rely on a simple JPQL that was calling the view. And remember that views are for JPQLs, same as queries, same as tables are for JPQLs. So you can use them in the same way. You can create an entity based on a view. And then what you can do when you have a large query, take a good look at it and analyze if you can pull a big part of it out and put it into a view, so that you can still continue using easily JPQL or criteria query from your application. I know we haven't discussed criteria query yet. It's one of the future lessons, no worries. And I'm gonna go to try that. So let's say just create view students, or view unique students as select all from student where and so I said unique, select distinct. Yeah, I know this is a dummy example. No, you don't create a view just to have the distinct students. You can just put distinct there and you have it in JPQL as well. But I do not afford now to have the time to write something complex and large, and it doesn't even make sense to do that. So let's say I'm running this, and this is it. This is my view, okay? And you can see a distinct name, student name, anyway. Something like that I wanted, but too late. Is too late today. Let's or even let's leave it like that. It doesn't really matter. No, the point is the same. So you create a view for what you need, and then what you do is you can create an entity for that specific view. No, so in my case it's called distinct student, and it's just a normal view, no, it's just a normal entity. So I'm just gonna use the entity annotation, and I'm gonna use the table. And yes, it's named table, but you can put here the name of your view. So what was the name of my view actually? View unique students, which means I'm gonna go here, okay, and then I'm gonna define, which for me like is exactly like a student but without the relationships. Okay, I don't want to put the relationships because it's not essential for what I want to prove here. Remember, views are you cannot change them, no, so they are immutable. They are just a way to display the data, so you will not be able to use views to change the data. And that's why now I created an entity here to for the select, but it's even better in a real world situation to also create a DTO as a Java record, for example, considering that you are using a version where you have records, or simply an immutable class, and use DTOs for your selection, okay. But to spare some time, I will avoid doing that, no. So look, I now have this entity, but this entity is now based on my view, and then what I can do is I can select based on the view, no. I can say entity manager create query. So I'm not using native query here. I'm using now JPQL, and I moved the native part into the database. So this is a trick, if you want to call it like this, a trick to avoid writing native queries where you would have that large complexity, and maybe you don't know, or you maybe even can't translate to a JPQL. But since I've moved all the complexity in the view, now I can simply say select as from, and my view, actually the entity representing my view, distinct student s. And yes, we have to be sure we don't forget to add it here, no. Normally in a real world app you'd probably not have to do this anymore, since you're most likely using Spring or something that helps you with scanning your entities. But you know, here I'm simply using Hibernate in a plain Java application without any framework, so in that case I need to put it myself. And then you say SQL gives me a distinct student, and run it as a normal query, no? So it's very easy. So you say typed query. I can use typed query, no? I can use typed query now because I'm using the create query method and not the create native query one. And then you say get result list, and you do whatever you want with it. Okay, so this is one of the possibilities. You have actually two possibilities. The second one I will demonstrate it immediately after this example. So first possibility, you have some complex query, you don't know how to put it. Come on, I missed something here. Mismatch input s. Let's see what query generated. Oh, sorry, too late for me today. I was missing the from word. Yeah, normally. So this is the first way is moving the complexity to a view such that you can still use JPQLs instead of native queries here, and then you can avoid in some cases. Yes, it looks like that because I don't have the toString. Okay, let me add the toString as well so we can clearly see it. And I've moved the complexity to a view. And of course, this works as long as what you do is a select query, but that's what we do in most of the cases. Now we have this select query and we can avoid putting complexity, and then you can avoid wrongly using native queries just because you feel you cannot put it correctly. You can see here clearly that the query that has been generated is selecting from the view, no? And yeah, we know the strange namings that come from the translation of the JPQL query. We have already seen them in the previous lessons as well. The second way in which you can move complexity, and it's even a more powerful way, it's using stored procedures. So an alternative is to again move part of the native stuff at the database layer through prepared so through functions and store procedures. And you fortunately have also an easy way to call a store procedure, and I can create one and I can prove how this works. But before I do that, let me read some more of your comments and see what you want to ask. So regards from Mexico. Hola Mexico. Hola Francisco. When you want to get data using complex join query and you still want to get pageable result, how to achieve it? I'm not sure if the complexity of the query, I need an example because I don't know what you mean here. Normally the complexity of the query is not affecting the way the pagination. No, you can get pages still even if you have a query that is, I know, 100 lines long. So probably you mean something else, and you can leave me in a comment, for example, an example of a query, and then I can clarify. But normally that should not be a problem. Then of course, if that is for any reason a problem, maybe the second thing that I will present here using store procedures can also be a way for a solution for your query. Do you use P6Py in real projects? To be honest with you, I have no idea what P6Py is. Maybe something I'm missing, but Georgie, you can clarify, because I don't feel it's something that I know or I'm experienced with. Could you please start a series on TimeLeaf? Maybe never thought about it. TimeLeaf is such a small framework that is not that often used, but why not? In the end, we can do that as well if you feel that it's something that will help you. Thank you for your appreciations, and good night from Cambodia. It's already late. Okay, late here for me as well. It's after work. You can see I'm not really fresh, but I will do my best to explain this stuff as well as possible. Yeah, I was saying views are one alternative, stored procedures are a second alternative. So what we can do is we can go here and try to run something that creates a stored procedure. Again, let's try something simple. We don't want to lose a lot of time. I will just write a select maybe with an ID and then prove how we can call it. But again, this will prove you how to move some complexity to the database level. Okay, so let's say we want to get students with an in parameter named ID of type int, and then what this does is it's selecting everything from student where ID is ID. Yeah, maybe not the best choice of the name, because here you don't know exactly what it is, but it should actually work. Or maybe we can do it like this and say SID is ID. And I think I should have actually changed the delimiter back to semicolon. So let's see. Oops. Oh, come on. Let's see if I manage to create this. Okay, here it is, and I can try to call it as well. So let's try to call this, say call, and then the name of our store procedure with an ID. Okay, and we see that it's working fine. So normally we should be able to call this procedure now. So now use your imagination. This is a very simple store procedure, but what you have to imagine now is that I had a complex query and I had to move it. Maybe a complex logic, no, because I said the store procedures, they are even more powerful. They allow you to have kind of logic and use it, okay? So you can do a lot more with a procedure than you can do with a view. A view is just a query. No, it creates you a table based on a query, but you cannot do changes through it. You can only make reporting through a view. No, it's only for reporting data and no more than that. But a store procedure can do much more than that. And if I want to prove that, I can go back and I'm going to say this is the name of my procedure. Oops, sorry for that. The name of my procedure, and then the class, what do we expect it to return, for example, if I create it through a query. And then you can register the parameter. In my case here, as you can remember, I have used a parameter. I could have used multiple parameters. You can register them and their type. So what was the name of my parameter? It was ID. And then what was the class for the parameter? It was integer, because I'm using an int number as a primary key, or a long, I don't know, maybe, but it will work with integer as well. And then the parameter mode simply tells me if it's in, out, or in, out. You know, in case of parameters for store procedures, you can have the parameter type, and then you just have to put it this way. And then I should say which is the value for this parameter, which I should say with set parameter here, and then the parameter. And then this creates me a store procedure query, which is actually query in the end. So I can use either query or store procedure query. Which normally now I should be able to say get result list and do the same thing like I previously did as well. So output the data. A very simple demonstration just to prove again that this is working. I left everything in the comments, so you can uncomment them. This will be on my GitHub account as usual. After the live latest tomorrow, I will push it, and then you will be able to see it and use it yourself, and try even more than I have done. If you have questions, leave it in the comment section, and so on and so forth. And you can see how easily exactly the same thing I was writing here, the call of the procedure, Hibernate did that for me. And then you can see that the result is the same that that I got also when running this from the MySQL client. And now again, use your imagination. Imagine I've moved natively a complex query, so I can still get decoupled as much as possible and avoid using native queries directly in the application. Okay, and now it's time to take the latest, the last questions, because as you saw it late already, and I have covered what I wanted to discuss with you. Fortunately, it was something that you've learned something good out of this, and you will be able to correctly apply it later. So let's see which are. I've watched all your videos from this playlist, and I got a question about the persistent context. I'm using data JPA. I'm not sure what data JPA is. Maybe it's Spring data JPA. Probably I trust that might be what you are using. And I have two different repositories. And I use with the same transactional service method. When I receive the two entities, they are in the same persistent context, or there are two separate. Okay, so you use two repository classes in the same transaction. The context will be per transaction. So those two instances, even though you get them from two different repositories, as long as it's only one transaction, they will pretty sure be in the same context. But you need to make sure that you have the transaction at the service layer, so that there will not be one transaction per repository, which will be the default if you don't use transactionability, but you will have only one transaction per use case. And in that case, everything that you grab, all the instances that you take from any repository that you use to create your use case, they will be in the same persistent context, in the same JPA persistent context. But again, that makes sense. Used for Hibernate logging? No, I haven't used that, George, so I cannot answer. Sorry for that. For me, for logging, was using standard stuff was usually more than enough. And then when I wanted to see more about queries, I'm using profiling, and for me it was fine up to the moment. I didn't feel I need something else, but since you told me about this, I will put it on my list here for things that I need to learn. So let me actually make sure that I write its name so that I can learn it as well. And thank you very much for suggesting it, because I always love when I have the chance to learn new things. Okay, this is it. And then store procedure can have in and out parameters. Yes, correct. That's why the parameter mode here, there are multiple kinds of parameters. Normally it's in, out, and in or out. To be honest, I don't even know what this cursor really is, but depending on the database technology that you are using, you might be able to use some of these, or you might not be able to use some of them, or maybe you can use all of them. So be careful. It depends usually on whether you're using MySQL, Postgres, Oracle, and so on. These syntaxes can differ from one technology to another, but to use them, the parameter mode gives you the needed constants that represent the types of the parameter. Okay, that is it. With that being said, I hope this was a useful lesson for you. Thank you very much for all your messages. Thank you very much for all your questions again. I'm still looking forward to your questions in the comment section. I was again very happy to be here with you today. I'm waving goodbye and wish you, as usual, an excellent time for learning further. See you next time.